Good morning, and welcome to the next iteration of ERA's ongoing webinar series. Today's webinar, Understanding Proficiency Testing, Statistical Analysis and Evaluation, will be presented by Craig Huff. Craig is the Senior Technical Manager at ERA and has over 26 years of experience in the environmental testing industry. He's an active participant on T&I subcommittees and currently chairs the FOPT Format Subcommittee. I'm your moderator, Jason Furness. Following the meeting, time permitting, we will be answering questions. Please put your questions into the questions section of the GoToWebinar series. Now, Craig.
Thanks, Jason. Good morning, everyone. I want to welcome you to the series, and I want to address some questions. The major question that we have very frequently here at ERA is, where do the acceptance limits come from that we apply to proficiency testing evaluations? How are they derived, and what tools are available to me to help me understand this before I submit proficiency testing data for evaluation? So, like Jason said, time permitting at the end of this webinar, if you do have any questions, please feel free to type them in, and I'll try to address as many as I can. So with that, let's get started.
Question from Thomas really quick. Yes, after the webinar, we will be posting a link to this on our website, www.eraqc.com. Okay,
let's start off with statistical analysis and evaluation of population data sets, some of the more commonly utilized models. The most common model utilized in the U.S. and the one we'll be talking about primarily today is NELAP, or the NELAC Institute T&I method or approach. There's also Z-scoring, and there's also pure study and population data approach. Z-scoring is something that's just recently come on board here in the U.S. as a method of determining how well you did against the population study mean. It's based on standard deviation units and where your result falls in essentially number of standard deviations away from the mean. Pure study population approach is just that. You look at the study data, the study mean, the study standard deviation, and evaluation statistics are all derived purely on the study data. As I said earlier, the focus of this will be primarily on the T&I approach, which can be fixed limits. It can be based on a study mean and based on regression equations to determine what evaluation and acceptance criteria are going to be applied. So with that, the T&I approach, or NELAP, it's accepted by most states either wholly, wholly being there's 13 official NELAC states, and most other states will accept the T&I approach in part, or some hybrid of that. The data are evaluated using regression equations or fixed limits. If you'd like more information on that, the T&I website on the FOPT tables, they have all of that information. It'll allow you to determine how is my analyte that I'm reporting assessed and evaluated. That all exists in the FOPT tables for drinking water, for non-potable water, for solid chemical materials. It's all right there. I'd encourage you to log on to the T&I website if you've got any questions specifically. And also, I'd like to note that any changes to regression equations and acceptance criteria will be published on that website as well. That's where everything originates. Let me talk a little bit about the NPW, or non-potable water acceptance limits. On PT reports, these will represent an approximately plus or minus 3 standard deviation evaluation interval. For drinking water, it's plus or minus 2 standard deviations. And data, with enough data points, they utilize robust mean and robust standard deviations for the statistical evaluation. Now, mean and standard deviation, robust versus arithmetic techniques. What's the difference? Well, arithmetic is just that. It's a simple average and simple standard deviation. PT providers typically use the simple for sample sizes between 7 and 20 data points. Robust mean, which is a multi-iterative bi-weighted mean and standard deviation, is a more reflective way to calculate mean and standard deviation without the influence of outliers. Okay, so what does bi-weighted really mean? Well, essentially it starts with the median of the data population, not the mean. It starts with the median, and it basically goes through multiple iterations and assigns a weighting factor to each data point with respect to where it's located or its distance from the median. And there's up to 15 iterations of this are conducted until the weighting values become supportable and acceptable for calculating out the true robust mean. And as I said before, this is utilized for sample sizes of 20 or more values. Okay, why would you want to use a robust technique? Well, primarily it minimizes the effect of data outliers on the mean and the standard deviation. So as an example, if you've got, say you have 22 data points and you've got one or two that are significantly distanced from the mean, you can weight that mean and you can weight that standard deviation significantly, and that would yield an unfair evaluation in a lot of cases. So this technique essentially weights those values out that typically could be classified as outliers and doesn't allow it to impact the true study mean and the standard deviation. Okay, another technique used by PT providers is outlier determination, and how do they treat that? One of the more common ones is the Grubbs test. I'm not going to go through the calculation in great detail with you, but I'd be happy to have a discussion with you or answer any questions on it later. Essentially, the Grubbs test statistic is the largest absolute deviation from the sample mean in the units of the standard deviation. And that's what's used by a lot of PT providers to determine what's an outlier and what's not. And again, that's utilized for data population groups of 7 to 20 sample data points. One general rule PT providers have to utilize in this case is to not use more than 20% of the values in a data set and classify them as outliers. So there are a lot of rules that PT providers have to adhere by, and they're all statistically based, and they've been approved by these PT providers' proficiency testing accrediting body. Okay, let's talk about PT regression equations versus fixed limits. Where do they come from? How are they derived? What do they mean? All of the regression equations and fixed limits that are commonly used by PT providers exist in the T&I FOPT tables, or fields of proficiency testing tables. I've taken an excerpt out of the wastewater or the non-potable water FOPT table just to show anybody here in case you haven't seen this before. I'm going to use nitrite, as you'll see it's highlighted in green. I'm going to use nitrite on the next slide as an example of how acceptance limits are calculated for national or the non-potable water accreditation. So as you'll see in this table, there's an A, a B, a C, a D column under acceptance criteria. Those are regression equations. A is the value used to calculate, or A and B are actually the values used to calculate the slope and residual of the assigned value. C and D are used to, and basically, let me back up a little. A and B will yield a predicted mean. And this is based on a lot of historical data accumulated by EPA, PT providers, method derived. A lot of different sources went into the calculating of these regression equations. So A and B are used to calculate a predicted mean within that concentration range. All PT providers have to manufacture their samples such that the assigned value falls within these ranges. The C and D values will give you a predicted standard deviation, and that's one standard deviation that will predict. So you'll see down there at orthophosphate is P, that's got a plus or minus 15% fixed acceptance limit. And all of the FOPT tables will have some form of this in there. Some will have no A and B factors or no predicted mean factors. Some will have a strict plus or minus 15 or 10% acceptance limit depending on the analyte. And some may just have a C and D or predicted standard deviation regression equation. So we're going to use nitrite in the next example to take you through the exercise of how an acceptance limit for NPW is calculated. Okay, so if we look at nitrite, if you recall, the A factor was 1.0017, the B was a negative 0.030, C 0.377, and D 0.025. Okay, we're going to use a PT sample assigned value of 1 milligram per liter as the example here, just to keep the math fairly simple. So the predicted mean, you will take the assigned value that the PT provider starts out with of 1 milligram per liter, multiply it times the A factor, and then you add the B factor. That gives you a predicted mean of 0.999 milligrams per liter. Then we calculate the predicted standard deviation. Again, you use the assigned value of 1.0 times the C factor, 0.0377, and then you add the residual 0.0250. So that gives you a predicted standard deviation of 0.0627 milligrams per liter. Now, for wastewater or NPW acceptance limits, you need to multiply that times three standard deviations. So plus or 0.999 plus or minus 3 times 0.0627 will yield an evaluation interval of 0.811 to 1.19 milligram per liter. Now, one of the things that I'd like to note about using a regression equation is that most of the analytical method bias is accounted for where regression equations are prescribed. So you don't have to worry about so much. If you're using a common method, you don't have to worry about your method yielding results that don't typically fall within the acceptance ranges. Okay, let's talk a little bit about how a PT provider determines their assigned values. The actual made-to value, as determined by weights or measurements, is one technique. PT providers are also required to take into account any substrate purities with the salts, metals, organic neat materials, whatever they're using. They have to take that into account when they calculate out a made-to value. Measured means established by the PT provider. That's for situations where there really isn't a good starting point to calculate assigned value by weights and measures. PT providers can use their internal measured mean by a commonly utilized method to determine the preliminary assigned value. And then obviously there's the PT study mean, and that's utilized primarily where only the predicted standard deviation factors are supplied on the FOPT table. Now, PT providers must be compliant with verification, homogeneity, and sample stability criteria, commonly referred to as VHS. Typically, a PT provider will have to, when they're measuring any lot of proficiency testing material, they'll have to demonstrate it's fit for use. Now, fit for use doesn't mean that they have to abide by the same acceptance limits that participating laboratories utilize. The fact is they have to utilize acceptance criteria internally that are 3 to 5 times tighter, typically. Okay, I'm going to transition into data modality now. This has been a kind of a hot topic amongst PT providers, regulatory community, and the laboratories. What is data modality? What is it and how is it handled? Well, multimodal distributions can occur where you have two or more distinct data distribution scenarios in an exhibited data set. So one way of looking at that is if you have one method that's utilizing that you utilize and it's reported with a significant number of data points that yields a bias that's say 10% lower than another method, you could have two distributions within a given data set. Now, PT providers are required to analyze for separate and distinct distributions and evaluate them separately. A lot of the data that went into the regression equations and the fixed limits on the FOPT tables already have a built-in, I mean, there are a lot of different method technologies that were utilized to derive the acceptance criteria. So, but again, not every method technology was utilized, just what was available at the time and at the disposal of the states and the TNI FOPT committees. What methods for detecting and treating these situations? The methods that are utilized must be approved by the PT provider's Proficiency Testing Provider Accreditor, or PTPA. These are the people that accredit a PT provider to provide PT samples and evaluate PT data. When detected, the PT provider must assess the cause and segregate the data and evaluate the data separately to give a fair evaluation to all laboratories. If they cannot determine that, they have to invalidate the sample or the analyte in that PT study, notify the participants, and that's usually resulting from an issue with the PT provider's actual PT sample. Now, this does happen. PT providers are human beings as well, but they are judicious in trying to assess and determine when these situations occur and evaluate it accordingly. Now, some potential causes of multimodality within a data set. There's prep and analytical method bias, which I've touched on already, i.e. two or more methods may not necessarily be equivalent. They may not yield the same result within the concentration range or the matrix that PT provider's sample design is based on. There could be PT sample inhomogeneity being exhibited within the sample or between the samples within a given PT study lot. PT samples may have exhibited instability during the course of the study. If you have an analyte that's starting to degrade while it's out during being tested for in the proficiency testing study, that will show itself in the PT statistics. Typically, PT providers have a vast database of data based on their sample designs, and they can tell pretty quickly if instability is the cause of a multimodal situation. PT sample concentration and its impact on acceptance limits. This is a pretty important one here. Where you have regression-based acceptance limits, typically the acceptance limits will change as a percentage of the assigned value over the PT concentration range. And generally speaking, they'll widen as the concentration approaches the lower end of the concentration range or the PTRL. Then there's fixed acceptance limits. Well, they're just that. They're fixed. Doesn't matter what the assigned value is. It's always going to be a fixed percentage around that assigned value. Now, let's talk about monitoring and trending PT performance. Some tools that people are starting to use and have gained a lot of acceptance on here recently are performance and exception reports. Most PT providers provide these. It's a quick summary of how you did for a given analyte within a given study, or you can track it across multiple studies. Performance reports will tell you how you did on your assessment. Exceptions reports will tell you how many analytes you didn't get an acceptable result on. One other tool that's available and at your disposal with ERA is our new custom export generator. This is a tool that you can define basically anything and everything associated with a PT sample. You can define and save the data you want in a report and generate it when you want. You can go back through multiple studies, multiple analytes, and basically define the report you want, generate it, and you can then download that into a CSV file, manipulate it to meet your needs, and use it as a tool for that purpose. Then there's Z-scores. Z-scores are a powerful trending tool, and they've been recently introduced here in the last few years, and they've gained a lot of acceptance. If you use it to track how you're doing between proficiency testing studies, you can develop a trend and find out how your data have been coming out relative to each of the different analytes. Now, what does that mean? Well, the Z-score, as I said earlier, it's basically how many standard deviations your result is from the study mean. You plot that with time across multiple studies, you can tell if you're trending in one direction or another, or if you have a bias that's in, high or low consistently. So it's a powerful tool you can use to help evaluate your performance and predict where your performance might be going forward. Okay. There's a lot of valuable information out there. Obviously, the TNI website at www.nelacinstitute.org. That's where you'll find all the FOPT tables, laboratory accreditation information, proficiency testing information. There's also the various ISO guides out there, 17025, Guide 3443. You can also contact ERA. ERA will be happy to share any of this information with you where they can. Our website is right there. So with that, I'd like to open this up for questions.
All right, Craig, thank you. Edward O'Neill asks, in robust calculations, do successive iterations remove outliers from the furthest to the closest, and what is the final determination as to what is included?
I'm sorry, I didn't catch all of that. Can you please repeat that?
Absolutely. In robust calculations, do successive iterations remove outliers from the furthest to the closest, and what is the final determination as to what is included?
Under robust analysis, outliers are not removed. They are weighted based on their distance from the mean. And essentially, the further away you are from the median, the lower the weighting factor is. So essentially, it weights it to a more insignificant contribution on the impact of the mean.
Okay. Pete Lovallo asks, can you explain Z-scores for dummies?
Can I explain Z-scores for dummies? Okay, that's a good one. A Z-score is calculated by, basically it takes your result for a given analyte in a given study. It subtracts the mean from that, and it divides it by the standard deviation of the study. So you're going to get a Z-score that can be either negative or positive, and it represents the number of standard deviations your result is from the mean of the study. So if you get a Z-score of 3.0, you know that you're 3 standard deviations above the mean of a study of an analyte. If it's negative 3, your Z-score is 3 standard deviations below the mean of the study.
Wanda Harney asks, can you give an example of how Z-scores can be used as a trend?
Yeah, for example, if you participate in, say, 2 years worth of WP studies, and you report arsenic in each of those studies, your Z-score will be a reflection of the standard deviation, your result of the standard deviation of each study for arsenic. So you plot that on a graph, and you can track based over time where your arsenic results are going. Are they going up? Are they staying flat? Are they dead on with the mean? Are they always above the mean? Are they always below the mean? And you can plot the slope with time to tell if you're heading in a direction that you may not want to be heading.
Thomas Hungerford asks, does number of labs involved in the study have any impact on the value of my lab's results? Is more better?
Good question. And to answer that, yes, more is better. It's a more representative data set. A lot of PT providers in general will struggle with a data set with a low number of data points. As I mentioned before, we have to switch to an arithmetic mean where the number of data points is between 7 and 20. Now, then we have to provide some judgment on the data there too. We look at the methodologies. We have to look at the bias of any given method and determine if it's multimodal. Now, when you have a low number of n's in a data set, bimodal scenarios are more difficult to detect. So to answer the question, with increasing number of data points, the better the data set will be and the more representative the evaluation interval will be.
Okay, we are still open for questions. In the meantime, I want to remind everybody that this presentation will be available at www.eraqc.com. It'll be both a link to a recorded version and a printable version. If you're having any problems at all, call us up, 800-372-0122, and we'll be happy to get the presentation to you.
Are there any other questions?
Dr. David Saldraga asks, how do you evaluate the influence of number of data points in a PT?
How do you evaluate the influence of the number of data points in a PT? I'm going to make an assumption that we're talking about a low number of data points and its influence on the overall statistical evaluation. Is that accurate? Let me just start by saying that when you have a situation where you've got very few number of data points for a given analyte in a study, a lot of things can come into play. Like I said before, first you have to look at the methods reported. You compare that to a historical database for the same sample design, might be a different concentration range, but it's all within the concentration range that are required to have the sample manufactured under. But you have to look at the sample design, you look at historical data from other studies, and then you have to use some professional judgment to determine, okay, is this a valid data set, and is it influencing the study data in question?
As a follow-up, Dr. David asks, I mean a PT having a low number of data against one having a large number of data. Thank you.
Well, a PT study with a low number of data, if you're using a T&I regression equation, you can always compare predicted study mean and predicted standard deviation. Typically, the acceptance limits will be, as I said before, the acceptance limits or the evaluations of each of the data points in that set will be determined by what that predicted mean and standard deviation calculated to be. Now, where issues come into play here are, particularly in a low number of data points, you might have an obvious bias, or you might have two data points that are way below the mean, two data points way above the mean. Then you have to take a look at, okay, what's a fair evaluation of the entire data population? So with a low number of data points, typically a lot more professional judgment is exercised, comparison with historical data, historical recoveries based on the methods reported, and then you have to determine, okay, what's in a fair acceptance interval in this case? And you have to be able to back it up. It has to be a defensible evaluation. In large data sets, the data pretty much speak for themselves. That's very statistically defensible.
Amy Rice asks, what if there are less than 7 data points?
Less than 7 data points typically will trigger that the PT provider go back to their historical database and take a look at all the factors that I've mentioned previously, method bias, compare that to the predicted mean and predicted standard deviation, and professional judgment has to come into play. Sometimes there's an obvious outlier in these low database cases as well. Professional judgment has to be used then after a Grubbs test or a Dixon test is conducted. Typically in a low number of data point population, though, outliers aren't as easily detectable. So again, a lot of historical data have to come into play in that evaluation.
Thomas Hungerford asks, our PT provider has a technician training samples. This is a good training tool to compare to the lab results and your lab result? Or is this a good training tool to compare to the lab result and the inter-lab result?
It's a very good training tool. A lot of labs also use that for demonstration of capability or compliance and use it to back up their training records with any given analyst. Typically, if you have one analyst that is always has a low bias relative to a study mean or other analysts within your organization, that's an opportunity that you can identify for to help that analyst become more proficient at it, performing that test.
Autumn Farrell asks, how do you know what method a PT provider is using to calculate the acceptance limits?
It depends on the study. All PT providers for T&I evaluations, all PT providers are required to use the criteria prescribed in an FOPT table. So if a PT provider A has a assigned value of 1.0 milligram per liter and PT provider B has a assigned value of 1.0 milligram per liter, those acceptance limits better be the same. And they're designed to be that way.
Milena Drogic asks, what is the difference between being above and below the mean value?
The difference between being above and below the mean value. Well, in any data set, there's always going to be above and below mean data points. If you're consistently above, you might have a high bias associated with the method that you're performing. And the same thing applies if you're on the low side consistently. It's an opportunity to take a look at, okay, is there something going on with the way I'm calibrating my instrument, something wrong with the technique? If you're way below or way above the mean consistently, that's an opportunity to identify that you might want to take a look at how you're doing or performing that method. Basically, as I mentioned, for a wastewater study or NPW, plus or minus 3 standard deviations of the predicted mean are what determine whether you get an acceptable or not acceptable result. Not everybody's going to be exactly 100% on the mean every time. Statistics will demonstrate that. But your distance from the mean with each given study and whether you're above it or below it will help determine if you've got a bias associated with what you're doing. Typically, if you're always within 1 standard deviation of the mean, I could argue that you're clicking on all cylinders and you're doing fine.
Dr. David Saldraga asks, is it correct to say it is better to participate in a PT having a large number of laboratories than one having a low number of participants?
My personal opinion on that is I would always prefer to have a large number of data points. Problem with that is, though, is that as a laboratory, you can't always tell what the population, a given PT provider, or how many data points a PT provider is going to have in a given study. That might be one of the decision criteria you use when you're evaluating which PT provider you want to use. Is it a PT provider who typically has a large number of data points consistently in a given study, or is it a PT provider that has low number of data points? Keep in mind that the lower the number of the data points, the more professional judgment has to come into play in determining acceptance criteria and evaluating participants.
Thomas Hungerford asks, What qualities should we look for in selecting a PT provider? Our state has an approved PT provider list that we must select from. I evaluate our current PT provider every year.
Well, obviously, one really good indicator or criteria is the number of data points a PT provider routinely has in a given study. If you have a large number of data points in a given study, the evaluation criteria is going to be a lot more straightforward and a lot less judgment goes into play. You also want to take a look at a PT provider sample designs. Is the design of the PT provider one that makes the analysis much more challenging? Is it one that is single analyte versus multi-analyte design? There's a lot of things that come into play, and you also have to consider the efficiency of how you test each of these analytes in your laboratory. Case in point, if you trace metals, for example, most PT providers have a large number of analytes in their trace metals mixes. That weighs on the cost. It reduces the cost to the laboratory. If a PT provider has analytes that are segregated into multiple study designs such that you have to analyze 3 samples in a given method to generate all the data that you want to report, that impacts the cost of conducting PT study testing.
Larissa Hoover asked, is there a way for me to know how the big data set, let me rephrase that, is there a way for me to know how big the data set was for the determination of the acceptance limits?
Actually, yes, there is. After the study closes, we can provide you the study mean, all the study statistics, including the number of data points in it. And that's routinely available for most PT providers right now.
Larissa, I think that answers your other question as well. Ruth Click asks, will this webinar be available again in the near future? Ruth, absolutely. It will be available on www.eraqc.com. And if you need to, give us a call, 800-372-0122, and we'll be happy to get that to you. Scott Frazier asks, how does a PT provider pick an assigned concentration for a study within the allowed range?
PT providers are required to randomly generate the assigned value in a given PT sample with each study. Now, what does that mean? Well, hopefully they have a system set up such that a random number is generated prior to the manufacture of each PT sample within the T and I concentration ranges. That way it's a more representative data population from across the concentration range. And basically I guess what I'm trying to say is a PT provider is not allowed to select one subset of the concentration range and routinely manufacture an analyte to that same concentration with each study. It's designed such that the entire concentration range gets represented across the studies over a given period of time.
Lori Berridge asked, what testing is done to ensure that a PT study sample meets VHS?
Well, it depends on the PT provider. I can speak for ERA. ERA uses more common methods that the actual laboratories are using. Not a lot of creativity goes into that. Keep in mind that the PT provider needs to have a sample that's fit for use. By analyzing that sample in their VHS program, using methods that the laboratories are actually using, the higher the chances are of success the PT provider will be able to meet the acceptance criteria. Now, that said, not all methods are capable of determining precision and accuracy data within a given published method. Certain things have to be modified. A PT provider might analyze a sample at a little bit higher concentration, for example, than what is required from the PT provider in the dilution instructions. Most PT providers will have calibration ranges designed around the PT concentration. All of these factors together can combine to help you, a PT provider, gain a better assessment of the accuracy and the precision in a given lot of PT material.
Larissa Hoover asks, fecal PTs always seem to have a huge acceptance range. Is the method for returning that acceptance range different from the methods we discussed here today?
That's a very good question. In fact, I know it's one that TNI is addressing in a coliform or a microbiological subcommittee right now. We are actively participating in that with the goal being that there's a lot of different methods out there for fecal coliform, total coliform, E. coli. A lot of the PT providers are also represented on that subcommittee, with the goal being assessing the different methods, understanding if there truly are biases between methods, and what do we do going forward. Now, microbiology being what it is, and the various sample designs that are being utilized out there today could have an impact on what the acceptance criteria look like and how wide disbursement the data population exhibit. So I'm anxiously waiting to see what comes out of the FOPT subcommittee on this and see what kind of guidance as well might come out of it. So that's about all I can really say on it right now.
Larissa Hoover asks, I'm sorry, we just answered that. Edward O'Neill asks, does anyone like yourself provide an asbestos PT sample?
ERA currently does not provide an asbestos PT sample. If you want to give me a call or an email after the webinar today, I'd be happy to do some research and find a PT provider that can provide that for you. Although I can tell you that it's been tough to find one here recently.
Scott Frazier asks, with multi-analyte PT samples, what is the general method of selecting which analytes are present? I noticed that less stable analytes are often not present. Is there a requirement to include those at some frequency?
There is a requirement that a PT provider provide not only analytes within the concentration ranges, but also that they try to cover the analyte list within a given field of proficiency testing. While it's true, and I agree there are bad actors in some mixes, PT providers still, at some point, must provide that analyte in a PT study.
Thomas Georgian asks, the use of accepted limits of plus or minus 2 to 3 standard deviations from the mean suggests normal data sets. How are acceptance ranges established for data sets that are unimodal but not normal or log normal? For example, are non-parametric tolerance or prediction interval used?
We have not come across that very frequently. Basically, the way the PT samples are designed and the acceptance criteria and the prescribed regression equations, fixed limits, what have you, basically make the assumption that the distribution is a normal distribution.
Pete Lavallo suggests for asbestos PT, try aiha.org. Dr. Salaraga asks, what do you think are the main characteristics differentiating ERA as a PT provider from the competitors?
Well, how about experience? How about the number of data points in a given study? ERA has been in operation since 1977, initially as a CRM manufacturer, but was one of the pioneers in the proficiency testing industry. Typically, you'll see with ERA, and I'm not saying this is true in all cases, but the number of data points in a given study is very significant. And as I mentioned before, you want a large number of N's in a PT study to make sure that you get a evaluation that is both statistically defensible and less dependent on judgment. Now, ERA's had a lot of experience dealing with PT sample designs as well, and trust me, that comes into play when you're trying to analyze a given PT sample. A lot of history, a A lot of knowledge and a lot of experience have gone into the design of our PT samples.
As a follow-up question from Thomas Georgian, you do not test for normality, it's merely assumed?
We do test for normality. Typically, well, actually not typically, we have in very few cases have we ever seen a distribution that was not typical. Now, when we have come across those situations, the PT provider must evaluate the cause of it because it's predicted to be a normal distribution. If it's not a normal distribution, other things can come into play. And generally speaking, where you get into those situations are associated with analytes with a low number of n's. So historical data comes into play when you're assessing that. Knowledge of the methods that are being used and reported comes into play in that. So essentially, I guess, normal distribution is assumed. If it's not exhibited, we have to investigate why.
Thomas Hungerford asks, how long do you maintain your clients' PT study results?
How long do we maintain those? That's a good question. Is that 3 years, 7 years, forever?
We have hard copies for 5 years, and then electronic copies indefinitely.
And with our new e-data system, you'll be able to access your PT data going back many years. So that's another thing you want to consider when you're trying to make a decision on a PT provider, which one you want to use.
If there are no other questions, then I think it's time we wrap up this webinar. Just want to remind everybody one more time that it'll be available at www.eraqc.com, or you could call us at 800-372-0122, and we'll be more than happy to help set you up with that. With that, I'd like to thank Craig, and thank everyone for attending.
Thank you, everybody.